topic is trigonometric integrals, or integrals of products and powers of trig functions. This is, if you're following along in the Thomas textbook, this is section 8.3 in your textbook. The goal here is to evaluate integrals of the form sine to the m x cosine to the nx dx, or secant to the m tangent to the n, or more generally, just if we have a trig function 1 to the m multiplied by trig function 2 to the n, that's the type of integral that we're talking about here. So let me first start off with what we're going to need to be able to evaluate these integrals. So the required tools are really the identities. This is the most important technique. Is we're just going to use identities to convert the given integral into a different form where it can be evaluated by techniques that we'll see. So of course, as I've mentioned earlier, the most important trig identity that we use in any calculus course is cosine squared plus sine squared equals 1, including its various rearrangements that allows us to write, say cosine squared is 1 minus sine squared. Equivalent identities that we can use are tan squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. Those are actually identities that you get just by you get those just by dividing by cosine by either cosine or sine. You would start with that identity. You can divide it by either cosine squared or sine squared and get the two identities below that. On the right, you see two other identities that are useful, which are cosine squared x equals 1 plus cosine 2x over 2, and sine squared x equals 1 minus cosine 2x over 2. Those are a little harder to remember because it looks, when you look at the first one, you're sort of expecting to see a sine 2x in the second one, but in reality, this cosine 2x is correct. Both of these actually come from the double angle formula for cosine. All right, so this is what you need in order to be able to evaluate identities of trig products.